This chapter deals with heat and temperature, especially how to measure and deal with temperature. Imagine you have a source of heat such as a flame, and you know you can bring your hand close to the flame without burning yourself. But if you take a piece of metal and you put it in the flame, pretty soon you'll burn your hand. This means that the air does not conduct heat very well, but metal conducts heat very well through a process called conductance. Even so, air and other gases and liquids can transfer heat through a process called convection, especially if the air is enclosed and if it's in motion. Electromagnetic waves such as visible light, radio waves, infrared, and ultraviolet light can carry heat through vacuum, and this process is called radiation. Here is a method for producing very high heat to melt iron and steel and so forth. When the diagram says high power electrical energy source, what they mean is we're going to take voltage and step it down to a very low level. That means the current will be very high, and it is the current that will produce very high heat. Here are two practical scales that are used every day to measure temperature. Notice though that there must be a reference, and the reference is the freezing point of water, and they're both different for Fahrenheit and Celsius. What's not showing on this diagram is the Rankine scale, which is related to Fahrenheit and is used in chemistry, and the Kelvin scale, which is related to Celsius and is used in more advanced physics. For the purpose of our class, make sure that you can convert from centigrade to Fahrenheit and back and forth using the formula shown in the diagram above. Here are two methods for measuring the amount of energy and temperature, and they're both related to water, except that the British thermal unit is very big, as you can see, as 1 pound of water raised 1 degree, but the calorie is very small, since it deals with 1 gram of water raised 1 degree Celsius. That is why when dealing with calories in food, we really mean kilocalories. A donut has 250 calories, it's really 250 kilocalories. When measuring temperature, we first think of thermometers, but there are many ingenious mechanical devices to also measure temperature. These mechanical devices always depend on different types of metal that when heat is applied, it will deflect in one direction or the other, giving us an idea of how much heat has been applied to the metals. Thermistors are solid-state devices that change resistance when heat is applied. The changes in resistance will be very small. For that reason, the thermistor must be used in a Wheatstone bridge, and usually the signal then must be amplified to get an idea of what has changed. Notice that the thermistor has a label NTC, which means negative temperature coefficient, which means that the thermistor will have its resistance go down when heat is applied. Resistant temperature detectors, RTDs, work the opposite of a thermistor because it has a positive temperature coefficient, which means that the resistance will go up as the heat is increased. Thermocouples are devices that use two different types of metallic wires, and then that way when heat is applied, a little voltage will be created, and which gives an idea of how much heat has been produced. The drawing in the diagram above is more correct than the book because it shows that in a thermocouple you have two wires, but one side is soldered together and the other side the wires are free, and it is the free side that is attached to an electronic circuit. Once again, the signal will be very small and must be amplified. Pyrometers are devices that measure temperatures by observing the electromagnetic waves that are coming off from an object that's been heated. Notice that energy can behave in three ways. It can be reflected, it can be emitted, or it can be transmitted. Here is a pyrometer that measures temperature by looking at the type of light that's being emitted from an object. Notice though that there must be a reference. In other words, there must be a certain type of light coming in so that you get a match and therefore gives you the idea of the temperature. This pyrometer takes light, but it also uses an array of thermocouples so that the light will strike the thermocouples and give you an idea of the heat. One thing to notice about pyrometers is that they're non-contact devices. That is, you are not touching the device that you're trying to measure. This table compares several devices and it compares at what temperature they operate. Notice that you can go from low temperatures to very, very high.